you want to hear?
What do you want to hear? Do you want to hear about thermodynamics or any random topic? Thermodynamics? Okay. So my name is Ajitesh. I will be talking about thermodynamics. When you hear that, doesn't it kind of sound complicated, like a college course or something? But really, it's the study of heat transfer between objects. So that's what thermodynamics means. Thermo meaning heat, dynamics meaning movement. Heat is it's commonly switched with like temperature. Heat is actually the transfer of thermal energy from a higher energy source to a lower energy source. Thermal energy being the amount of kinetic energy in an object. In regards to thermodynamics, a system is an environment that is studied for the sake of measuring thermal energy. Potential energy, you may have heard of potential energy. It's the amount of energy an object is capable of having. So this is usually related to gravitational potential energy. So if I take this eraser and I have it higher up, generally you assume that it would have more energy when it's falling, right? It would move faster. So it is capable of having more kinetic energy when I drop it. So that is potential energy. Radiation is an object's ability to emit molecules or energy. So when you hear about uranium or plutonium having radiation, it means that when those elements break down, they emit beta particles, which are able to penetrate our skin, and that's why they're so dangerous. They're able to harm our organs and injure organs. A calorie. You guys have heard of calories, right? You guys are watching your calories, I hope. Except my sister. My sister needs some calories. A calorie is a unit of energy. 1 calorie is the amount of energy that is used to boil 1 gram of water, so that's kind of interesting. Kinetic energy, I talked about that before. Kinetic energy is the energy of motion. So if I'm not actually going to start, but if I threw this marker, it would have kinetic energy. Everything in the universe has kinetic energy. The molecules in this table are moving just a little bit. They're all moving a little bit, and that's what thermal energy is. The average kinetic energy every single molecule in an object has. I'll talk about what happens or what it is if an object has 0 kinetic energy. So, endothermic reactions. Endothermic reactions are when an object goes through a chemical reaction and absorbs energy from its surroundings. So, have you guys seen those hand warmers at football games? So when you shake them, they get warm, right? So that's an endothermic reaction. After the reaction occurs, it absorbs energy and has a higher thermal energy after the reaction. So it's low, and then after the reaction occurs, it has a higher energy. An exothermic reaction is a reaction that expels energy from the original source. So fire, combustion, you guys have seen fire. When you light something, when a combustion reaction occurs, the source has higher energy first, and then it has lower energy. The energy expelled is expelled through light or heat, and that's fire. Now, thermal energy, I've explained that. Specific heat. Specific heat is the amount of energy required to raise an object's temperature a certain degree. So, I don't know the specifics, but to raise a certain object's temperature 1 degree takes like a certain specific heat, and that's measurable through other things. Absolute zero is what I was talking about before, when an object's average kinetic energy is 0. That's actually impossible because as the universe is a closed system, nothing gets in or out. The average kinetic energy of the universe it stays the same because nothing can leave it, nothing can come in. So a molecule cannot stay still. That's theoretically it's possible, but it is impossible in the universe. Next we have entropy. Entropy is disorder in the universe. If we think about Earth as a closed system, its entropy is always increasing because entropy is also related to heat, and as we know, global warming, it exists. So the entropy of Earth is actually constantly increasing. When Earth was formed, the entropy was very low, but as humans evolved and created fire, we actually spiked the amount of entropy and heat in the Earth's atmosphere incredibly, and that's just climbing. That's going to continue to climb, and all we can do is hope to slow it down. Enthalpy is the opposite of that. That's order. When an endothermic reaction occurs, when an endothermic reaction occurs, it absorbs heat and reduces the chaos or disorder in the surroundings. So that's enthalpy. And finally, we have Kelvin. Kelvin is another unit of energy. If we think about this room right now, I'm really cold right now. So just an example of where thermodynamics can apply. This room is very cold, and you can't just pump a bunch of air conditioning cold air into this, or else it'll just mix with the warm air and become warmer, right? So that warm air needs to go somewhere. You can't just reduce like the temperature or energy of something without giving that energy to something else. So all the hot air in this room is actually going outside, and that's thermodynamics. Thank you.
Why don't you explain what that you learned from this workshop helped you prepare this beautiful presentation about thermodynamics?
So, Coach here, he taught us some mnemonics for me personally. He taught me the sprockets. So, I changed it up a bit because I wanted to add more
That's exactly
words.
what I wanted you to do. Yes.
So, T is thermodynamics, H is heat, E, I think I switched up the E for thermal energy, so E is energy. Yeah. S is system, P is potential energy, R is radiation, C is calorie, K is kinetic energy, E is endothermic and exothermic reactions, S is specific heat, and then I added Zeek, that's not a word, but Z-E-E-K, Z is absolute zero, E is enthalpy, E is entropy, and then K is Kelvin.
Right. So, simple things like mnemonics, acrostics, figuring the right brain, and all of that, all this information that he shared with all of you, he already had it in him, and most of our children have it. What they struggle with is recall. So if you give them simple tools and resources, everything that's in there waiting to come out finds a structure, finds a path, finds an easy, meaningful, contextual method in which all of it can be articulated and expressed. I mean, did he beautifully explain thermodynamics? Yes. Great job.